So hello, my name is Jean-François Gagné. So I'm talking about replication today. So I'm a senior infrastructure engineer at MessageBird. So this is my title at MessageBird, but I consider myself a system and MySQL expert. If you want to tweet, you can use the DataOps hashtag, and my Twitter handle is there. It's a little small, sorry about that. So just to talk a little about MessageBird. So we are a cloud communication platform. I would call that like new telco. So we offer telecommunication service over the internet. Think about sending text messages, one-time password, and we do voice and SMS workflow. We have a tool called Flow Builder that can integrate many flows in a telecom system. So we have a lot of customers. We're a company that is growing, 200 plus employees. So quite an interesting startup or scale up because we're in the growth phase. We have offices all around the world, and we are expanding. If you want to work with us in Amsterdam, work with me, just come to talk with me, and we'll see if we can do something. Like we have a lot of positions open. The company doubled in size in the last year. So summary of this talk, overview of the replication landscape, and I will give you broadly overview, talk about pitfalls, things you should know, and give you a pointer about things to learn more. I like to call this talk what I would like all my colleagues to know about MySQL replication. So I will introduce replication, talk about some generalities, zoom into use cases, do a little war story, and closing remarks on scalability and sharding. No need to take pictures. I will put the slides online. So don't use camera or something. Everything will be online. So you can focus on what I'm saying. What is replication? So how does it work? We have a master and one or many slaves. When a commit is happening on the master, data is sent to InnoDB and the binary logs. The binary logs is the replication journal. Everything that is sent through replication is written to the binary logs. On the slave, there's something called the IO thread that download those binary logs and write them into relay logs. So this is a local buffer of unexecuted transaction on the slave, but now it's on the slave. It's somehow a copy of the bin logs of the master. Then there's the SQL thread that take those relay logs, put them into InnoDB, and maybe write them to other bin logs. So a slave can also add bin logs. This is optional for being another master. And there's something that is interesting. It's the delay between the moment where something is here on InnoDB and the master, and when something is in InnoDB on the slave. So it involves many steps. So there's a delay here called the lag. This is what you want to use replication. There's 3 groups of use cases. The first one is mostly about backups and risk management. So being able to do point-in-time recovery with the binary logs. Instead of taking the backups on the master, you take them on a slave. I'll come back to that. And eventually, you can also have a delayed slave to have a copy of your data a few hours ago to be able to recover from whoopsies. There's also scalability reasons. Reading from slaves, reliability of reads, and availability of writes. I'll touch all those in more details later in the talk. And there are also other use cases that I will talk about a little less, but there's multi-source. Ghost is leveraging the bin logs to be able to do schema changes, replicating to Hadoop, testing new versions. So replication is useful to do those things, but I will not touch a lot of on those. So if you're starting from one master without any slaves, and you want to set up replication, you need to configure 3 things. First, you need to enable binary logging on the master. this is not enabled by default on MySQL 5.6 and 5.7. It is enabled by default in 8.0, but if you're running an older version of MySQL, you have to enable it yourself. You also have to set a server ID, and this is dynamic. It's a good thing. And you have to create a replication user. Everything in the manual how to do that is written, so we'll not come back on this. There's also a server UUID. So the server ID and the server UUID identifies a node in replication. MariaDB as server ID only. Is this still working? Yes. MariaDB as server ID only. MySQL from 5.6 as both server ID and server UUID. This is needed for GTID. You don't have to set it yourself. It's set automatically, and it's stored in a file. And there's also the binlog format. There are many formats for the binary log. There is row-based replication and statement-based replication. From MySQL 5.7, it's row by default. Yeah, it's row by default, and before it's statement. If you start from scratch with MySQL 5.6 or before, I would advise going row-based replication, because the new features of 5.7 and 8.0 relies on row-based replication, so quicker parallel replication, group replication. It needs row-based replication, and changing from statement to row is a big pain, so I would advise going row-based replication. It's less important with MariaDB, where parallel replication works well with statement-based replication. And once you've set all that on your master, then you take a backup, you restore a backup on a slave, and then you start replicating, and everything works well. So this is how you set up replication. There's one thing I kind of mentioned, but I haven't detailed. I did not go into detail yet. It's GTIDs. So MySQL 5.6, from MySQL 5.6 and MariaDB 10, have a feature called GTID, and you probably want this feature. If you're starting from scratch, enable GTID, because it's a pain to enable GTID yourself later. So if you start from scratch, enable GTID. If MariaDB 10.0 come with GTID for free, you don't need to enable them, you have them already. If you have a setup that is like already prepared and you don't have GTID, it's like you're kind of stuck. You'll have to enable it yourself. In MySQL 5.6, it involves stopping everything and enabling GTID starting again, so you will have a downtime. There's a way to do that in MySQL 5.7. It's in the manual. So GTID is a feature that, like, I have a love-hate relationship with GTIDs. It's a nice feature because it allows to repoint slave. It's very useful for maintenance, for high availability, but it comes with a lot of like drawbacks. There's something about Binlog server that I like. This is an advanced subject. I will mention it a few times, but I will not go into details there. So a few like things that you need to know about replication. There's two things: binlog do DB, binlog ignore DB. Those are weird features. Be very careful if you use them. I won't go into details, but there's a nice blog post explaining like why you should be careful. There's similar things about replication filters. And like really read this blog post, make sure you understand everything in it before using those two features. About slaves, so log slave update on slave, so generating binary logs on slave is not by default in 5.6 or 5.7. I'm not sure about 5.7, but you probably want that. So enable this. And one thing, replication crash safety is not enabled by default in 5.6 and 5.7. It is in 8.0. What this means is if a slave crashes, it might not be able to restart replicating when it comes back up. So make sure you enable replication crash safety, because if not, when a slave crashes, like either MySQL or Linux, you need to restore a backup. And it's quite easy to deploy. You just set two variable. you change your configuration file, and it is something you can do online. You don't need to restart MySQL for that. But if you have GTID, it needs sync binlog equal 1 and trx commit equal 1. So if you're running with those 2 parameters relaxed, you cannot have replication crash safety. So it's a bug that I've opened. To finish about general piece before diving into a more advanced subject, so a large replication setup is quite hard to keep in your head. So there are tools. So there's orchestrator and PT slave find, which are visual, which gives you an idea of what is your replication setup. If you have a replication setup, get used to one of those 2 tools. They're very useful. Orchestrator is a little long to install, but it's worth it. It's the best visualization tool that I know of. There might be others, but it's very nice, and it can be used for failing over. If you don't have time to set up orchestrator, just make sure you're able to run PT slave find. This is way easier to set up. And now I'm going into more advanced subject of replication. So maybe 1 or 2 questions about that before I continue everything I said, just to make sure everything is clear. Yes. Yes, orchestrator is open source. I have links at the end of the presentation.
Your microphone is from time to time.
I know it gets quite close to my mouth. I cannot do.
No, I think it's limitation.
Oh, it's okay. I'll try to move less. Other questions before I continue? No? Okay, so one thing that I mentioned is lag. So this is the biggest problem you can have in a replication setup. It's when the slave is lagging. It means it's not up to date. There's 3 types of lags, but I won't go into detail about lag because Simon Mudd is giving a talk just after this talk about how Booking.com is dealing with lag. So I will let him go into the details of lag. There's still slides in my presentation about this, but I will go quite quick. So there's ways to monitor lag. Simon will describe those things. This is something from Booking.com. And the techniques to prevent lag, Simon will explain everything about this. Well, one thing that Simon might not cover is this, sync binlog equals 0 and trx commit equal 2. This is a magical recipe to speed up MySQL, but it comes with quite big consequences. I have a whole talk about this that I did at Percoma Live in Frankfurt last year. You'll have to read the blog post about that. So now we will go into the use cases. So this is the reminder of the use cases. This is exactly the same slide. I will talk about backups, scalability, and I'll skip this part. So backups. So if you do not have slaves, if you only have the master, you don't need reliability, you're completely happy with a single master, you have to do backups on that node. So there are ways to do backup online, or you start MySQL, you do a backup. If you're lucky to be in a setup where you don't need MySQL to run all the time, you can stop MySQL and do your backup. But not everybody is in that situation. And doing an extra backup on a master has consequences on the performance. So taking backups on a slave, so adding slave just for backup is fine, and it's quite useful. So if you do backup on slave, it's less disruptive, all the same solution as above, MySQL dump, extra backup, copying the file system when MySQL is stuff, everything, all those are possible. Personally, if you have slaves, I prefer to stop MySQL, take a copy. Like you should be able to do that if you're HA. If you're I available, you should be able to stop MySQL, and this is quite convenient to do backups. And so you can still do an extra backup, but extra backup will fail in some situation. So adding slaves is also a way to have extra copies of the binary logs. So if your master goes away and you only have a backup from an hour ago or like 24 hours ago, and you completely lost the master, adding a slave is a way to have the binary logs and being able to replay those binary logs on restoring a backup. So it's quite an expensive way to do that, but it works. And be careful again, your bin logs might not survive a crash if you don't use single non-equal one. And there's delayed replication. In the past, there was a tool in the Percona toolkit that was called PT-slave delay that was keeping a slave by a few hours or a few minutes of lag. And that was quite useful a few times, even at booking or other places, where there's somebody that thinks he is in staging and he drops a table, but oops, he's in production. You want to restore that table without restoring a whole backup, like adding a delayed slave is perfect for that. Even at MessageBird, I have delayed slave by 24 hours. So if a dev is doing an error, I'm able to recover for 24 hours this problem. So I'm telling all my devs, hey, if you do something you're not sure that it worked with the data, come to me quickly so I can fix this. In MariaDB 5.6 and MariaDB 10.0 and MySQL 5.6, there's a parameter master delay in change master 2, so we don't need PT slave delay anymore. And that's very reassuring as risk management. So that's about backups. Now we're going to talk about reading from slaves. So reading from slaves, you might want to do that for those 4 reasons. The first one is from a resilience point of view. So if you have a slave, or even if the master fails and you want to still be able to read, reading from slave is quite interesting. You can also read from one or many slaves. So if one slave is down, you can still read. And usually applications are split into business function that you need to write to a master and some business function where you only need to read. And so adding slaves for resiliency, for being able to do things with the part of the business that is only needing read, is quite useful. So scaling, obviously, if you read more than what a single server is able to handle, adding many slaves is useful to be able to read from many slaves. That doesn't work for writes though, because there's still, the master is a single node, and all the writes you do to the master needs to be processed everywhere. There's also performance reason. So sometimes we have very long queries, like analytics and things like that. Having dedicated slave for those queries is useful, because those queries will use a lot of CPU and they might cause problem with the rest of the traffic. So splitting reads on quick reads and slow reads is useful. And latency, so if you're on a multi-data center, like MessageBird, we have infrastructure everywhere in the world, so we want to be able to read our data quickly. So we put a slave in the US, in Europe, in Asia, and then we're able to read quickly. So those are the main reason why you want to read from slaves. But there's a complexity involved with this. It's related to lag, and I will let Simon talk about this. There's another complexity, and it is, where do I read from? And this is basically a service discovery. So your application needs to know where is your slave, or where are your slaves, because you might have more than one. So this is a service discovery problem. And so there's DNS, proxy, pooling, a lot of solutions. So at scale, you probably need some pooling and dynamic service discovery with Zookeeper. There's literature on the internet about this. But if you're small, just start with proxy SQL with a load balancer in front of it for high availability, and you're in business. And there's a talk about proxy SQL either later today or tomorrow. So if you're interested in that, just go see Renee. He will talk about this. There's 2 talks about proxy SQL. There's one with Orchestrator. It's Matthias that gives the talk. Is there? Like, just wave. And Renee is talking about proxy SQL. So if you want to increase read resiliency, there's one thing you should not do. And so this is an anti-pattern, so don't do this. So reading from the master, and when the master is down reading from a slave, it's a bad idea, because it will expose lag problem only when your master is failed. So read from slave all the time, and if you only have one, then fall back to the master, because if not, you will have lagging problem, you will not realize it, and then your problem will bubble up only once in a while when your master is down. So this is a design pattern, and that needs to be avoided, but it comes with like a notion of let's make the situation that we use most of the time, like the situation, like when there's some error, we want to see those errors. We don't want to hide those things under the carpet. When you design distributed system, you need to avoid bubbling problem only once in a while. You want always those problems in your face, and I will come back to that. Simon's talk, bad way to cope with lag 1, 2. This is also in Simon's talk, how to do consistent reads. And now we'll talk about high availability, but I can take 1 or 2 questions about reading from slaves before talking about high availability.
How do you ensure, what techniques do you have to ensure that data read from the slave is not stale? Or
You mean dealing with lag?
Yeah.
Yeah, I will let Simon answer that question in the next talk.
Okay.
There are tricks, and I don't want to like do too much of
Sure.
Simon's talk. But there are tricks, and like one of them is like just monitoring lag. Like the first thing that I can, like without going into the details of Simon's talk, just monitor lag. And if you see lag, just page an operator and fix the problem. Like that's the first step. There are obviously other steps. Like at some point the operator will be tired of being paged. So you want to do like other things. Yeah. Yeah. Like Simon has some tricks to like avoid paging people. Other questions about reading from slaves or backup before I go into HA?
I'll give a quick hint. Don't write to the database, then there'll be no lag. Don't write to the database, then there'll be no lag. That always works. It's guaranteed to work.
Other questions before I go into the HA subject? No? So let's go with HA. So high availability of writes. It's a big subject because in a MySQL replication setup, you have many slaves, so you potentially have many candidates for reading, but you only have one master. So it's a single point of failure, and when it fails, you cannot write anymore. So also sometimes you read from the master, like when you need to before doing a transaction, maybe reading from the master is acceptable. Simon will talk about that more. So when the master is down, you cannot write and you cannot read from the master. So you're basically down for some of your business function. So being able to react to the failure of a master is critical in a replication setup, especially if you're an e-commerce company or if you're a gaming company. So I will spend a lot of time on this subject. So there are solutions to restoring the master. First thing is, if it crashes, restart the master, right? It works. You will be down until the master will be restarted, but it might work just for your personal WordPress blog. That might be enough. But what if the hardware fails? You won't be able to restart it. So you can also put your database on shared storage. So if the hardware fails, then you restart the database on another server that has access to that storage. And NetApp or other companies will be happy selling you very reliable storage. So this storage is usually quite reliable until there's a system administrator that plays with it and make it down and bring it down. So storage fails. Most of the time, it's a human error that involves the storage failing. And also, when you do that, when you restart MySQL on another node with the same storage, you need to do crash recovery in the database. This takes time. And also, you start with a cold cache, so your database will be slow. You can fail over to a slave. But what if somebody drops the database? So all those solutions here have drawbacks. So you need to be able to cover for those. And failing over to a slave is my favorite solution. And what about dropping a database? You manage this with delayed slave or backups.
Yeah, but then you need a lot of time to replay the logs until the point of time
Yes.
of the failure.
Yes. So restoring a backup takes time. I have a solution for that. You basically need to be very good at restoring a backup. Or you need to take backups very often. So file system snapshot helps here. And delayed replication also helps. So if you have a delayed slave by 10 minutes, it will not be very long to catch up 10 minutes of replication. So delayed slave helps a lot there. So we'll talk a lot about failing over to a slave, but this is actually quite complicated. Just said like that, the master goes away, you fail over to a slave, but in reality, it's very hard to do, and it's hard to automate well. The people that are automating this are getting outages because of their automation. So I will talk about such an outage just after that, but I will have to explain the whole thing before. So GitHub has a nice architecture. I hope to be able to present message-word architecture at Percom Live later this year. So I wrote a blog post. It's quite a long post explaining all the steps of failover. The first thing is to plan. What are you going to do? Failing over to a slave. Decide when you fail over. This is failure detection. I'll come back to the details of failure detection. You have to tell the application of the change because the master was there before and now it's somewhere else. So this is service discovery. You have to protect, again, the limits of failure detection and service discovery because if something goes wrong, you'll end up with a split brain. You're writing at both places or your data is inconsistent, and that's pretty bad. So you have to protect against that. And if this happens, you need to fix your data. So I'll go into each of those steps in the next slides. There's also way more details in the blog post I wrote. So failure detection is the first part of failing over, and it's actually quite a big challenge because it's a very hard problem. Anybody that is telling you that he has a very easy way to do failure detection is wrong. This is wrong. Absolutely, don't trust somebody that is telling you he solved failure detection. Who is familiar with the halting problem? This is an impossible problem in IT. Failure detection is also an impossible problem to do in distributed system. It's possible to do when you simplify the model, but those simplifications are do not work well with partial failure, unreliable network partitions. So it's impossible to be sure at 100% that something failed. And it's also very hard to have a good confidence in a short amount of time. So if you are if you're losing a lot of money in your business when your master is down and you want to do something quickly, you will have a lot of false positive. You will think your master is down, but it's not actually down. It's maybe a little slow, and you will fail over, and then you risk the split brain. So quick failure detection is unreliable, and relatively reliable failure detection implies longer unavailability. So you need to accept that you will have false positive or false negative. And usually we don't want false negative, because when you think everything is well and your master is down, you lose money in your business. So you will go on the side of false positive. And I will come back to the problem with false positive. Then you need to reorganize your replication. And this is quite easy. Like once you decided, I apply my plan, failure detection is telling me I probably have a master failure. Repointing is easy. Like there are tool, MHA, GTID, pseudo GTID, binlog servers. And if you don't have too many slaves of the master, like this is relatively easy to do. And there are softwares that help for repointing. So what do I mean by repointing? If I have this very simple setup, one master, two slave, this is actually a setup we have at MessageBird. If the master fails, one of those two will become the master, and the other one will be the slave of the new master. We could think that by doing this here, we avoid the problems of repointing, but repointing is easy. Like once you have failure detection and the next step that I will talk about, like that's not such a good thing to do, because now you need to deal with this guy's failure. Here you do not, like you only have the master, and if a slave dies, you're not in too many problems. But here, if this dies, you need to deal with the intermediate master failure. And also, you cannot do that for all deployments. So this is another deployment at MessageBird. So we have the master in one European region, two candidate master in other data center, and we have slaves everywhere in the world. Failing over here, I cannot avoid repointing. So I have to reorganize replication after a failure. So repointing, it's complicated at scale, but it's simple to do. It's a problem that is quite straightforward to solve. Failure discovery was hard. Failure detection was hard. Service discovery is the other thing that is hard. So if you have centralized service discovery is telling your application, where is my master? So if you have centralized service discovery, you have a single point of failure. If you have distributed service discovery, it's harder to update. So service discovery will either introduce a bottleneck for either a single point of failure, a performance bottleneck, or some sort of problem when something goes wrong in service discovery, or it will be at scale, and then it's hard to update in an atomic way. So there's some ways to implement service discovery. Shlomi blogged about this. And then a statement that is quite important is that unreliable failure detection and unreliable service discovery, one or the other, is a recipe for split brain. So a split brain is when you're writing at two places at the same time. So if you have a partial failure and then the master comes back up and you're writing at both places, so now your data is corrupted. Or there's other forms of split brain that are more subtle, but in the end, your data is corrupted. So there are ways to protect against split brain. They're all advanced subjects. So there's stun it to stop the master. Another way that I'll talk later. And proxies and well-configured semi-sync might help. I'll come back to semi-sync. The last step, fixing your data, well, I cannot help you with that. Like, you know what your data. So when you write at two places and when your data starts to be corrupted because of a split brain, you have to know what you do. And it's not maybe not you, the database operator, maybe the developer will know that. I have one thing, avoid auto-increment, and we'll see why. Auto-increment as a primary key is not the best thing to recover data in case of split brain. UUID help. And I will justify that in that Booking.com war story. So I gave a full talk about that, so I'll do the short version here. And GitHub has a quite interesting postmortem. So if you want to know more, read their postmortem. And if you have war stories like that, just share them. Like everybody failed somehow at master automation. And it's good to share failure because we share learning and we avoid each other's error. So a very simple setup at Booking.com. We had one master where writes happen, a slave in the same data center, candidate master in the other data center. Reads are happening there. Everybody's happy. We like the system. And then something goes wrong. Everything fail on that data center. Both node goes down. So it happens. So the solution is just to put the writes there on X. So now everything is good. And we're done. So we go to sleep, and then we wake up to this. So now the writes are happening there. What happened? And reads are still happening there. So what happened here is that we wrote here for a few hours. Something messed things up. I cannot go into the details. But now we're writing and we're reading here. We have data that is not here and that is here. We're reading data that we're not writing. It's a mess. And not only is when this fails, let's say we were at auto increment 100, we allocated 101, 102, and so on there. Maybe we're at 200 now. And when writes go back there, we go at 100, 101, 102. So now we have violation of our unique key in our data. So it's a mess. And so fixing the data would not have been easy. So you can understand whatever you want from that sentence. Because of auto-increment, and UUID would have made fixing the data much easier. So one lesson from this, master failover is hard, and auto-increment might not be your friends. Like UUID are better, and one day I will do a lightning talk about the dark side of auto-increment. So yeah, it's a hard problem. And some people might say, hey, I have a magic solution. This is cycle replication. Don't go there. I don't have time. So read the slides. I don't have time to talk about this. A lot of things can go wrong. The right way to do it is to avoid cycle. Like this goes down. Okay, you do failure detection. You put your write. You update service discovery. You make sure you fence, like you stop replication. Because if you don't stop replication, you'll have writes that come back from P when P goes back. And hopefully you have no writes here if you do things well.
And if you set it read-only?
Yeah, well, how can you set it read-only if it's down? If you think it's a good idea, and you still think, hey, I can do that, like write all the time at both. And if that doesn't scare you and you think you're able to handle that, well, okay, go there. But don't do like this setup unless you're writing at both all the time, and then you have conflict and all problems. So Galera and Group Replication are the only multi-master solution. So Galera and Group Replication, they do not provide better failure detection. Failure detection is hard. They will provide an agreement on failure detection, but Galera and Group Replication are not better at knowing if there's a failure or not. They're quite good at data consistency, but they will protect your data at the cost of failing a commit. And I don't know about you, but failing a commit for me is not high availability. So I am not sure that those solutions are actually more available than standard replication. It's very interesting for fencing, but it doesn't work with multi-data center, or it's still unclear how to do that. And you're still stuck with asynchronous replication, with group replication if you want to go cross-DC. Semi-synchronous replication is very interesting. It has some properties of Galera and Group Replication in the sense that you will not lose committed data in semi-sync after a failure. And it's quite interesting for fencing. If your master needs to write to a slave, to send the data to a slave before committing a transaction, you can fence your master. So if you think there's a failure, just stop the slave that is semi-sync, and then nothing will commit on the master. And that's a good way to protect data. Pseudo GTID, just a quick thing about this. If you have a hard time deploying GTIDs, or you're stuck in an old version of MySQL, you can use pseudo GTID. I'll skip that. Same thing about that. So replication is quite a wide subject. I brushed a little of everything that I know of and that I want my colleagues to know and my friends to know. I also gave you pointers to learn more about different subjects. Simon will tell you more about lag. In the abstract, I told about problems with foreign keys and unique keys and auto-increment. So I covered auto-increment. So foreign keys and unique keys, basically they will be in your way when you will shard. So when you will arrive at a bigger scale, enforcing unique keys across shard is hard. Enforcing foreign keys across shard is hard, so you won't be able to do it. So just don't do it in the first place, right? Don't put that in your way of scaling. So if people in your organization start to use those features and you think that at some point you'll have to shard and you'll have to scale your data set, tell those people, hey, try to do without this because it will be in our way in the future. In the slides, I have 5 pages of links. So I have to acknowledge, like Simon Plum from Booking.com, I inspired some of my content to his talk. And then I have a lot of replication topics that you can read more about. More of this, and more of this. Message Bird, we're expanding. Come to me if you want to know more. Simon's talk. Yeah, Simon's talk is how Booking.com avoids and deal with replication lag, just like in 15 minutes after me in this room. And now I have time for questions. Question? Everything was clear? You learned something? Yeah. Cool. Yes?
It's just about being a master or master slave. Why did you...
Yeah, just one thing. You mentioned master. So master for me is a word that is ambiguous. What do you mean by master? Do you mean Galera group replication? Yeah, you mean ring replication. So cyclic replication. So I prefer to use cyclic replication here or like Galera because master is a word that I would like to see less in the general public.
I agree with you.
Yeah. So cycle replication.
Okay, cycle replication or replication master slave. You're afraid about ID of increment, but why just choose offset or auto-increment?
Yeah, that doesn't solve the problem. That solves the problem for insert. So the question is about cyclic replication. You can use different auto-increment offset for writing on both. So that makes your insert safer if you're using auto-increment, but don't use auto-increment. And also, updates are a problem. If you update the same thing on the one node and then on the other node, it will replicate this way, and then you end up with two different values. So like your data, so cycle replication doesn't enforce any consistency on your data. And you will end up adding inconsistent data. We can talk about this more after the talk. Any other questions? Well, thank you very much for coming.